While no one can make the job easy, we can make it very manageable and safe. But the responsibility for proper installation, handling, and removal resides squarely with you, the user. At Plug-It, we can't control or predict the workplace variables that affect your safety. Every job is different, and the safest plug in the world can cause injury or death if it's not properly handled, installed, or safety practices are ignored. So it's up to you, but we can help you in a very big way. During the next few minutes, we're going to discuss items covered in our safety manual, which include how to safely install, handle, and remove our plugs. We'll deliver a product that will give you safety, service, durability, and confidence. But that doesn't just happen. You have to pay attention to the environment, the product, and the procedures. Remember, the environment, product, and procedures. If you have any questions, call us before you proceed with installation or handling. Don't guess. We're going to cover 18 points in this safety briefing, and following this, we're going to give you a product demonstration. Number 1, check your tools. As with any repair and maintenance procedure, it's important to use only the proper tools designed for your task and know how to use them correctly. Inspect your tools closely to ensure that they're in proper working condition. Maintaining consistent and accurate air pressure is extremely important when working with plugs. Be sure that your pressure gauges are calibrated accurately and capable of holding a steady pressure setting. Failure to maintain consistent air pressure can result in plug failure, resulting in possible injury or death. Also, be sure that you are utilizing any specialized tools or equipment that may be required by local, state, or federal regulation. Number 2, evaluate the job. Individual and unique characteristics of the working environment can greatly influence the proper repair procedure and affect the performance of personnel and equipment.
Actually, it's the supervisor's responsibility to examine each situation, and from experience, he'll know the traffic flows in his area.
In addition, the supervisor must be aware of any local, state, or federal regulatory requirement that may be required to ensure worker or public safety. It is extremely important to allow only experienced personnel to function in this decision-making capacity. Provide close supervision for individuals considered to be assistants or are in training. Failure to recognize inherent dangers at the job site can be deadly. If anyone is unsure of any aspect regarding safety, do not proceed. Consult your supervisor, safety engineer, or governing authority for proper instruction. Number 3, secure the job site. Reroute pedestrian and vehicle traffic as necessary by placing traffic cones, or provide other security measures as outlined by local ordinance or as required by governing authorities to ensure worker and public safety. Do not allow unauthorized or untrained personnel inside the work perimeter. This is for their safety and yours.
So this is part of securing the job site, is keep people away from this area. If you've got pressure in the pipe or a plug in the pipe, and especially a plug in the pipe with pressure behind it, air pressure especially, you don't want people around the manhole down the street.
Number 4, test the atmosphere. The work area may contain toxic or flammable gases or be oxygen deficient. It is important to ventilate confined areas such as manholes before allowing anyone to enter the work area. Always ventilate a manhole, starting from the bottom. Noxious gases are usually heavier than air and will be found in greater concentrations at the lowest levels.
And you don't want to send your workers down an area that has poisonous fumes, poisonous gases, or displaced oxygen. Maybe not poisonous, but if there's no air, then his lungs fill up with something else and he can pass out.
Remember, always reinstall the ventilation hoses after lowering the workers into the manhole. Number 5, Use proper entry procedures. Never work alone. When entering confined workspaces, ensure that the line tender utilizes the proper harnesses, ropes, gloves, and other safety equipment. Consult with your supervisor for established safe entry procedures and correct equipment to use.
Or use products that eliminate confined space entry. We can help you with that. You stand on top of the manhole, you insert the plug, you've got the rope and hose coming up to the top where you can inflate and deflate it. Once the plug's inserted, you simply unscrew the pole, you leave the plug down in the hole, inflate it, and you never had to enter. When you're done with the plug, you simply deflate the plug from the top with this inflation-deflation fitting, and then pull it out with the rope. You never had to go in there.
Number 6, clean the pipe. Our pneumatic plugs are designed to be used in clean, dry pipes only. It's important to remove any debris from the area within the pipe to ensure a proper seal.
You don't want sharp objects, rebar, anything sticking up that could damage or puncture the plug when it's inflated.
Failure to clear the pipeline of debris will cause the plug to slip and fail, resulting in possible injury or death. Number 7, inspect the pipe. Inspect the pipeline for evidence of damage, cracks, or breaks.
You don't want cracks in the pipe. If this plug's inflated to, let's say, 30 psi, that's a lot of force pushing out against that pipe, and it could shatter the pipe.
Plug pressure applied to damaged pipe can further damage the pipe, causing the failure of both pipe and plug. Number 8A, measure the diameter of the pipe. Carefully measure the inside of the pipe you will be working with to determine its diameter. Measure this dimension in inches. Number 8B, determine the back pressure. The pressures that a plug must withstand are measured in PSIG, pounds per square inch gauge. These pressures can be calculated by determining the height of water that accumulates, head feet, at the center line of the pipe. Always calculate the maximum height of water that may accumulate. Please refer to the conversion table located in the safety manual.
There's two types of back pressure. The most dangerous back pressure is air. The second type of back pressure, of course, is water, feet of water head. Air is expansive. So in a case of, let's say you've got a pipe full of water and the plug scoots a little bit, then that water has more space, it's got more volume, and it actually goes down a little bit. If a plug scoots with air behind it, it really hasn't reduced. That air is so expansive that little scoot hasn't reduced it very much. It's still fully charged, and it could fail. So air is the most dangerous. It's expansive. PSI is PSI. 5 PSI of water pressure is the same thing as 5 PSI of air pressure, but because of air pressure being expansive and compressed in there, it's like a bomb.
Number 8C, determine the pipe's area.
Now that we've shown you how to measure the pipe's diameter, simply take that number, divide by 2, and that will give you the radius. Now that we've determined the radius, simply multiply the radius times the radius times pi, which is 3.14, and that will give you the total square inches of the pipe's area. Now that we've determined the total area of the pipe in square inches, simply multiply that number times the anticipated PSI, and that will tell you how many pounds of force the plug must withstand. The PSI is determined by either how much air pressure you need to test at, or how many feet of water head is going to be behind the plug. In the case of feet of water head, please refer to our table in our safety manual to convert feet of water head to PSI.
Number 8D, calculate the total pounds of force the plug must withstand. Simply multiply the total PSI times the total square inches of the pipe. The resulting total will give you the total pounds of force that the plug must withstand. Example, 10 feet of water equals 4.33 psi times 2,827.431 square inches equals 12,200 242.77 pounds of force. Now that you have calculated, number 1, the total back pressure being exerted, number 2, the total pipe area in square inches, and number 3, the total pounds of force the plug must hold back, you are now ready to select the correct Plug-It Products plug to suit your job application. Number 9, select the proper plug. Our plugs are clearly marked with minimum and maximum usage ranges. Select the proper plug for your particular job application. Select an air hose that is long enough to place you outside the danger zone during plug inflation and use. Warning: if you do not have the right plug for your specific application, do not proceed. Using the wrong plug or overinflating a plug to compensate for exerted pressures can result in plug failure, pipe damage, injury, or death.
This is one of the ways people get injured, property gets damaged, and people get killed. So you've got to know what you're doing. You can't take this lightly. When you know what the back pressure is and the conditions it's got to work under, you can select the proper plug. Now, whether you're buying from a distributor of ours, or I don't really care if you're buying another company's plugs. If you want to call us or email us with questions about which plug to pick out, I would rather have you do that and get the right product, whether it's ours or somebody else's, and have you work safe, than take a chance and buy the wrong plug and have a failure. So we'll discuss any application with you, whether it's ours or somebody else's. We'll discuss the application and make sure you're getting the right one.
Number 10, inspect the plug. Always inspect the plug for damage before putting one into service.
Check, make sure all your fittings are tight, the rope's in good shape, the D-rings on there, the pin's in there, your gauge is on 0, it's not starting at 10.
Okay.
The valve operates, okay, there's no gashes. Inspect it, make sure it's in good shape. Make sure the eye bolt here is not ripped in half or broken or bent. It's in good shape.
If the plug looks questionable, do not use it. Damage may consist of, but is not limited to, bulges, cuts, abrasions, loose or distorted fittings, or apparent bond releases. Important: mark damaged or questionable plugs with brightly colored paint and set aside in a separate location for repair or disposal. Failure to carefully inspect a plug before use could bring dire consequences: property damage, injury, or death. Use of a damaged plug may result in plug slippage and failure, resulting in property damage, injury, or death. Number 11, clean the plug. After carefully inspecting the plug for damage, clean with detergent and water.
Before you can thoroughly inspect the surface of the plug, make sure it has been cleaned with a soap and water solution, preferably with a pressure washer.
Allow the plug to thoroughly dry before use. Repeat this cleaning procedure after each use. Never use solvents or petroleum products to clean plugs. The rubber composition and bonding materials used in their construction may be severely weakened, resulting in catastrophic failure of the plug. Number 12, install bracing and backup system. Tremendous and potentially deadly forces are present when plugging a pipeline. It is therefore absolutely essential that you provide bracing for the plug to ensure your safety in the event of an accidental dislodge. This block or brace should be designed to contain a dislodged plug and all materials behind the plug should the plug fail during use. Consult a registered engineer for proper design and construction of such a brace.
Another technique that it's an old technique that no one seems to use that we think is outstanding, is double plugging, where you have a plug here and one right behind it. If the one behind it were to fail, you've got this one as a backup.
Additional backup plugs placed upstream from your main plug may be used to prevent leakage and reduce the pressures on the main plug. Never rely solely on a single plug to prevent property damage or leakage. Always provide a backup system. Number 13, warning, always avoid the danger area. This is an area directly in front of the pipeline and plug. It is an invisible funnel-shaped zone, increasing in size as it moves outward from the plug. It is essentially a blast area, acting much like the explosion of launching a projectile from a cannon. Should the plug fail, the plug and accompanying debris will launch outward with a tremendous and deadly force. Surrounding obstacles may also deflect flying debris. This ricocheting factor adds a further unpredictable element to an already dangerous plug failure.
So you've got to be aware of this danger zone. This is from the public's point of view, from a worker's point of view. Like I say, it can come down the pipe to the manhole down the street and blow the lid off. And I guarantee you when the lid blows off, there's going to be some person standing on that lid when it goes.
A human being does not stand a chance in front of this blast zone.
To better understand the hidden dangers you may be faced with, let's break down what happens when a plug is used to hold back pressure. The formula for calculating pipeline forces and pressures is force equals pipeline area times pressure. Consider the following examples. An 8-inch plug used in a 4 psi test is subjected to over 250 pounds of force. The same 4 psi test in a 48-inch diameter pipe is restraining over 7,200 pounds of force. Standing in front of a plug during this air test would be like standing in front of a loaded cannon with a lit fuse. A plug deflated before the back pressure is released can cause serious injury and even death. A plug should never be deflated while back pressure is still in the line. More importantly, a plug should always be deflated remotely using an extension hose. Never, ever deflate a plug within the danger zone. The force of that plug is equivalent to a missile shooting straight at you. When the force of a plug dislodging under back pressure has been known to knock over heavy machinery, it's obvious that you don't stand a chance. In Arlington, Texas, a contractor was finishing up the installation of 18-inch sewer pipe. To test the line, the contractor followed the sewer air pressure test procedure outlined in ASTM F1417, a 3.5 psi test. The line passed, and all that was left to finish the job was to dismantle the test equipment and remove the test plugs. Unfortunately, a malfunctioning gauge indicated that the test pressure had been exhausted, when in actuality it hadn't. Thinking the back pressure was exhausted, the job foreman sent an inexperienced 18-year-old to remove the back plug. But the plug did not have an inflation hose attached. The manhole was shallow, and he climbed down and began deflating the plug. By now, I'm sure you can guess what happened. The plug blasted out of the line and thrust the worker against the manhole. 24 hours later, he was dead, having suffered from fatal head injuries. If these kinds of accidents are going to be stopped, you are a major part of the equation. Proper use of confined space equipment, remote inflation hoses, regulated air sources, plug blocking devices, and an understanding of inherent hazards can prevent injury and death.
Number 14, attach the inflation airline and ropes. Use caution. Improper attachment of inflation hose may cause the plug to deflate unexpectedly, resulting in plug failure. Number 15, lowering the plug into the pipe carefully.
Lower it into the pipe carefully and place it carefully. If you're using a pole, that's beautiful. We don't want any damage to the fittings or the hose. The plug hits and pinches the hose and puts a little weak spot in the hose, and the hose fails later. It's not good.
Carrying handles and metal eye bolts are provided for handling the plug. Never use the eye bolts or carrying handle to secure a safety rope or as a means to restrain the plug during deflation. These items are not designed to withstand the pressures and forces involved. Number 16, carefully insert the plug into position. Insert the plug into the pipeline a minimum of the diameter measurement of the pipe.
as it slides along the bottom, if you feel something, maybe you want to pull it out and see if it's got a piece of rebar sticking up. If you can, look around inside the pipe there to see what might be in the way. Give it a final check.
Do not allow the plug to protrude from the pipeline while inflating. Do not insert the plug over or near sharp objects or obstruction. Do not insert plugs where two pipes intersect. Plugs are designed to work by applying plug pressure evenly from the sides of the plug. Number 17, inflate the plug. Check the air pressure gauge. Ensure that the pressure is holding steady. Partially inflate the plug. Check the air pressure at the gauge. Repeat this cycle of inflating and checking until the plug is fully inflated to maximum air pressure.
When testing or back pressures are going to be applied to the plug, that's when you really want to look at this thing and make sure that, yeah, okay, we're ready to go. It's been good all day, checked it every couple hours, whatever, but now we're going to apply back pressure, we're going to release flow or put in air. You want to be sure, one final check, and then watch it. Keep an eye on it, but stay out of the danger zone. That's why these things are 20, 30 feet long. We don't want you in that danger zone.
Tape off the air valve to prevent accidental pressure release. Continue to monitor air pressure gauge. Ensure consistent pressure. Never exceed the maximum air pressure. Failure of the plug will result. Never use an underinflated plug. It will slip and fail.
This is the part that separates us from everybody else. Our plugs, our 500 series, 600, and 650 series, are equipped with pressure relief valves in the plug. And what this does is help prevent overinflation of the plug. As long as that relief valve's in there and working in a good shape, you're protected from all the other people who have used this plug in the past. Because if you overinflate or overstretch the plug, it may not blow up this time. It may blow up next time. It may blow up a year from now. The 600 and 650 series are used extensively in trench safety rental companies who rent these plugs out. And as you know, no one ever said, "Be careful with that plug, Joe, it's a rental."
Number 18A, deflating the plug. Before attempting to deflate the pneumatic plug, you must release all pipe pressure. Remove the tape that secures the air valve. Number 18B, slowly decrease the air pressure until the plug is completely deflated. Remove the plug slowly using handles or by pulling off the half-inch ropes attached to the metal eye bolts provided for that purpose. Do not attempt to pull the plug from the pipeline before the plug is completely deflated. Do not use the air inflation hose to pull the deflated plug from the pipeline. Inspect and clean the plug before storing it away for future use.